Okay, good afternoon. In the last lecture, we seen that one theorem, let V be a finite dimensional vector space over the field F. Okay, माझा आवाज क्लिअर येतोय व्यवस्थित?
Yes, sir.
Yes, sir.
जर काही प्रॉब्लेम असेल तर आता सांगा. ओके, मला सांगा इकडे. Let V be a finite dimensional vector space over the field F. Let B is equal to alpha 1, alpha 2 up to so on alpha n be the basis for V. And beta star is equal to, B star is equal to F1, F2 up to so on Fn. Be a dual basis of V star. Okay, dual basis of, okay, V star. Then for each linear functional F on we have F, we can write in the form of summation 1 I is equal to 1 to n F of alpha I into Fi, and alpha, each vector alpha in V, we can write in the form of summation I is equal to 1 to n Fi of alpha into alpha. Okay, we see in this theorem, and also we see in one remark or one note, let V be a finite dimensional vector space over the field F. Then B and beta star, B and B star is isomorphic to each other. Okay. Now the next point is, the next theorem is, look at this one. Theorem. Let V be a finite dimensional vector space. Let V be a, instead of finite dimensional, we can write n dimensional. Be an n dimensional vector space over the field F. Okay, over the field capital F. If alpha is any non-zero vector, okay, belongs to capital V. Let alpha is a non-zero vector in capital V. Okay, then there exists a unique linear functional, sorry, instead of unique, there exists a linear functional only. Okay, there exists a linear functional, at least one. Okay, linear functional on F on capital V, such that F of alpha is not equal to 0. Okay, what is this statement? Let V be a n-dimensional vector space over the field F. If alpha is a non-zero vector in V, then there exists a linear functional, okay, functional F on V, such that F of alpha is not equal to 0. Okay, any doubt in the statement? Any doubt in this statement?
No, sir.
Okay. Now, proof. Since alpha is not equal to 0, okay, which is given to us if alpha is a non-zero vector in V. If alpha is not equal to 0, then the singleton non-zero vector is what? Linearly dependent or independent? Singleton non-zero vector is linearly independent vector, and we know that any linearly independent set we can extend to form a basis for V. Okay, एखादा जर linearly independent set असेल तर त्याला आपण extend करू शकतो. त्यामध्ये vectors we can add some non-zero vectors and linearly independent vectors in that set, and that becomes a basis for V. Okay, so again we know that every linearly independent set can be extended to form a basis basis for capital V. Any doubt?
No, sir.
Okay, now let B is equal to the set B is equal to alpha, alpha 1, alpha 2, up to so on. Alpha n be a basis, be a basis for capital V in which assume this alpha 1 is equal to alpha. या अल्फा मध्ये आपण काय केलं सेट मध्ये अल्फा 2 अल्फा 3 अप टू सो ऑन अल्फा n. ओके, एक्सटेंड केले आहेत याच्यामध्ये ऍड केले. So it becomes a basis for V. Okay, now in which in that set alpha 1 is equal to alpha now. Now let again B star is equal to the set B star is equal to F1, F2 up to so on Fn. Be a basis, be a basis. Okay, dual basis instead of basis, it is a dual basis for V star. Okay, so then by the definition, of dual basis, what we have? We have, it implies then Fi of alpha j is equal to what? Delta ij. Okay, so this is the definition of dual basis for V star, where it is equal to 0 when I is not equal to j and it is equal to 1 when I is equal to j. So particular, in particular for if I is equal to 1, we have, what we have? This is F1 of alpha 1. Okay, take alpha j is equal to what? Alpha 1 and I is equal to again 1. So F1 of alpha 1 is equal to 1. Okay, so this implies what is alpha 1? Alpha 1 is nothing but alpha. So F1 of I and j is equal to 1. Take. Okay, F1 of alpha 1 is equal to 1, but alpha 1 is alpha. So F1 of alpha is equal to what? 1. And F1 of alpha 2 is 0 up to so on. F1 of alpha n is equal to 0. Okay, so this shows that there exists at least one f. Okay, at least one f. There exists a linear functional. There exists a linear functional. Assume that f1 is equal to f. Okay, on capital V such that f of alpha is equal to 1, which is not equal to 0. So that is f of alpha is not equal to 0. Okay, so there exists a linear functional f for a non-zero vector alpha such that f of alpha is not equal to 0. ओके, हा तुमचा f म्हणजेच काय? f1 आणि अल्फा म्हणजेच काय तुमचा अल्फा 1. ओके, एनी डाउट?
No, sir.
Okay, so let V be the n-dimensional vector space over the field F. If alpha is the non-zero vector in V, then there exists a linear functional F. At least one linear functional exists F on V such that f of alpha is not equal to 0. Okay. Now the next point is Kausler. Let capital V be a n-dimensional vector space. Be an n-dimensional vector space over the field F. Over the field capital F. Okay, if f of alpha is equal to 0 for all f belongs to V star. Okay, what is V star? The collection of all the linear functional on V. Okay, so for all f belongs to V star, we have f of alpha is equal to 0. Then, if f of alpha is equal to 0 for all f belongs to V star, then alpha must be 0 vector. Okay, so this is the statement. Okay, now proof. Wait a minute. Suppose suppose f of alpha is equal to 0 for all f belongs to V star, which is given to us. This statement f of alpha is equal to 0 for all f belongs to V star. Okay, and we have to prove that alpha is equal to 0. Okay, now suppose the contradiction statement if alpha is not equal to 0. Let or assume alpha is not equal to 0. Okay, then by previous theorem, what we have? Then by previous theorem, there exists a linear functional, a linear functional small f on capital V, such that what we have? F of alpha is not equal to 0. Is it correct?
Yes, sir.
So if alpha is not equal to 0, then by previous theorem, there exists a linear functional f on capital V such that f of alpha is not equal to 0. Okay, एखाद्या वेक्टर जर नॉन झिरो असेल तर f of alpha पण तो नॉन झिरो असेल. But this is contradiction to our assumption. Why? Because we have f of alpha is equal to 0 for all f belongs to V star. Okay, so which is contradiction to our assumption. Okay, so hence we must have this alpha becomes 0. Alpha is equal to 0. Okay. If alpha is not equal to 0, then by previous theorem, what we have? F of alpha is not equal to 0. But what is given to us? F of alpha is equal to 0 for all f belongs to V star. प्रत्येक V म्हणजे V star तुमचा काय? याच्यामध्ये सगळा सेट मध्ये काय तुमचे सगळे फंक्शन्स आहेत. ओके, f1, f2 up to so on fn. Okay, for all fi, we have fi of alpha is equal to 0. Okay, but by the previous theorem, if alpha is not equal to 0, then f of alpha is also not equal to 0. There exists at least one function f on V such that f of alpha is not equal to 0. Okay, but this statement is contradiction to our given statement, this one. Okay, hence we must have alpha is equal to 0. Okay, any doubt?
No, sir.
पुन्हा वाचा एकदा स्टेटमेंट. सगळे स्टेटमेंट घोळ करतायत. ओके, थिअरम्स भरपूर आहेत त्याच्यात, खूप आहेत. नाव द नेक्स्ट थिअरम इज let again the same statement, let V be an n-dimensional vector space over the field F. Let capital V be an n-dimensional vector space over the field capital F. Okay, if alpha and beta are any two vectors are any two different vectors. Okay, different vectors in capital P, then there exists a linear functional f, small f, on capital V, such that f of alpha is not equal to f of beta. Okay, for the two different vectors in V, we have hmm, two different vectors in capital V. We have different images in our फंक्शनल म्हणजे तुमचा कोडोमेन काय असेल? एम आय ऑडिबल? ऐकू येतोय ना?
Yes, sir.
For the two different vectors alpha and beta, we have two different images in capital F, the field F. Okay, here the linear functionals means our codomain is small f is the function from vector space V over F to capital F. ओके, जर दोन डिफरंट वेक्टर्स असतील तर त्यांचे इमेजेस पण काय डिफरंट असतील. ऍटलिस्ट एक तरी तुमचा लिनियर फंक्शन असा एक्झिस्ट होईल जो काय असेल 1 1 असेल. इज इट करेक्ट?
Yes, sir.
Okay, 1 1 ची कंडिशन काय आहे? इफ अल्फा इज नॉट इक्वल टू बीटा, then f of alpha is not equal to f of beta. Okay, now answer proof. हा स्टेटमेंट सांगतोय काय तुम्हाला? जर म्हणजे ऍटलिस्ट एक तरी तुमचा 1 1 फंक्शनल एक्झिस्ट होतोय. ओके, नाउ लेट alpha and beta, let alpha and beta be any two different vectors or distinct vector. Any two distinct vectors, okay, in capital V, that is alpha is not equal to beta. This implies alpha minus beta is not equal to what? 0. Is it correct?
Yes, sir.
Now by previous theorem, then by previous theorem, what we have? There
F of
exists
alpha minus beta not equal
not
to
equal to 0. Okay, for non-zero vectors in V, we have f of alpha minus beta is not equal to 0. Okay, so then by previous theorem, there exists a linear functional on V such that f of alpha minus beta is not equal to 0. But f is what? Linear functional. So this implies f of alpha minus f of beta. Okay, taking c is equal to 1 and d is equal to minus 1. F of ax plus by. What we have if f is linear? A into fx plus b into fy. Now taking a is equal to 1 here and b is equal to minus 1 now. Belongs to the field f. So this implies f of alpha minus beta is not equal to 0. This implies f of alpha minus f of beta is not equal to 0. What is the reason? F is linear. Okay, so this implies f of alpha is not equal to f of beta. Okay, actually ही प्रोसेस कशी आहे? राइट हँड साइडला घेऊन जायचं नाही बरं का. f of beta belongs to field f. This is belongs to the field f. So there exists a inverse element, additive inverse exist होतोय. ओके, so याचा additive inverse काय येईल? असा आहे तो प्रोसेस. Okay, then plus minus this becomes additive inverse is 0. So this is f of alpha is not equal to f of beta. Adding both sides by additive inverse of f of beta. Okay. Any doubt? So any two
No,
different
sir.
vectors we have. There exists a function f such that their images are also different. That is the function is functional is one functional. Okay, up to here. काही डाउट असतील तर विचारू शकता. Otherwise, we can take the new point, the double dual. Okay, dual space, dual म्हणजे कळालं तुम्हाला dual basis. Now we have to the next definition is the double dual. Any doubt up to here?
No, sir.
Okay, now the next definition is double dual. Okay, नीट लक्ष द्या, हा जरा कन्फ्यूज करणार आहे क्वेश्चन. If first we will see what is dual space of V. Okay, if V is vector space, V is what? Vector space over the field F. Over the field capital F, then collection of all linear functional functionals from V into capital F, which is denoted by what? Denoted by V star. Is what? V star forms a vector space over the same field F, which is called the dual space of V. The dual space of capital V. Okay, so this is the definition of dual space. Now, what is the double dual? The collection of, this is the definition. Okay, the collection of all linear functionals from V star into F. ओके, इथे काय केलंय? व्ही स्टार तुमचा फंक्शनल डिफाइन केलं. कलेक्शन ऑफ ऑल लिनियर फंक्शनल व्ही स्टार इंटू एफ. ड्युएल मध्ये काय होतं? कलेक्शन ऑफ ऑल लिनियर फंक्शनल फ्रॉम व्ही इंटू एफ. So here in double dual, the collection of all linear functional from V star into F, and it is denoted by V double star. Okay, it again forms a vector space over the field F. Okay, over the same field capital F, and which is called double dual of capital V. Okay, dual space of V star. Okay, double dual कोणाचा आहे? V चा, and dual space of V star. Okay, so V star is nothing but what? In the symbolic form, we can write V double star is equal to, okay, the all collection of all linear functionals. Okay, suppose that functional is L, such that L is the function from V star to F, which is linear. ओके. ह्याच्यामध्ये सगळे मेंबर्स कसे असतील? द सेट ऑफ ऑल लिनियर फंक्शनल फ्रॉम V star to F. What is V star? V star is collection of all linear functional F from such that F is the function from V to capital F. Okay, दोघांचा डिफरन्स नीट लक्षात ठेवा. Any doubt in the definition of double dual?
No, sir.
ओके. हा तुमचा जो सेट आहे हा पण वेक्टर स्पेस फॉर्म करतोय ओव्हर द फील्ड एफ. ओके, हा पण वेक्टर स्पेस फॉर्म होतोय ओव्हर द फील्ड एफ. आणि हा जो व्ही डबल स्टार तो कोणाला आयसोमॉर्फिक असेल तर तो या तुमच्या ओरिजिनल वेक्टर स्पेस व्हीला हा आयसोमॉर्फिक असतो. ओके, ते पुढे आहे एक थेरम. ओके, सो दिस इज द डेफिनेशन ऑफ double dual, the collection of all linear functional from V star to F. नॅचरल एम्बेडिंग शिकलाय? नॅचरल एम्बेडिंग लिनियर फंक्शनल अनालिसिस नॅचरल एम्बेडिंग झालंय का तुम्हाला ह्याच्या आधी? नसेल झालं.
No, sir.
Okay, the collection of all linear functional V star into F is denoted by V double star and it forms a vector space over the same field F, which is called as double dual of V. Okay, double dual of V or dual space of V star. Okay, now the next definition is isomorphism. What is isomorphism? If F is the function from the vector space U to V is isomorphism if it is 1, 1 onto an homomorphism. Okay, so here instead of homomorphism, we can write F is linear transformation. Okay, if F is 1, 1 onto and also F is the if linear transformation, then that function is isomorphism. Okay, so the definition of isomorphism. Let capital U and capital V be a vector space over the same field F, over the field capital F. Then the mapping F from U onto V, capital V. Okay, it's called, instead of writing onto F from U to V, right? Okay, खाली आपण घेणारच होतो F. A mapping F from U to V is called an isomorphism. An isomorphism of U to V if F satisfies following condition. F satisfies the following conditions. The first one, F is 1, 1. Second, F is onto, and instead of homomorphism, right, we can write F is linear transformation. Okay, दोन्ही कंडिशन सेमच आहे. होमोमॉर्फिझम म्हणजेच linear transformation. That is F of C alpha plus beta is equal to C into F of alpha plus F of beta. Okay, if you take C is equal to 1, then this is the condition like homomorphism. f of alpha plus beta, f of alpha plus beta is equal to f of alpha plus f of beta if c is equal to 1. Okay, where alpha and beta belongs to V and C belongs to capital F. Any doubt in the definition of isomorphism?
No, sir.
Okay, now we will see the theorem on isomorphism. Let V be a finite dimensional vector space over the field F. Let capital V be a finite dimensional vector space over the field F. Capital F. If alpha is any vector in V, any vector in capital V. Okay. Then the functional L alpha on V star. The function. Okay, look at here. Function L to the suffix alpha on V star. Defined by L alpha. आता इनपुट काय असेल तुमचा? What is input? L alpha of L alpha is the function on V star. What is V star? The collection of all linear functional on V. Okay.
L
And
alpha
it
of F.
L alpha of F. V star मध्ये काय तुमचे सगळे functions आहे. Okay. Now, if alpha is the any vector in V, then the function L alpha on V star. Okay, defined by L alpha of F. Okay, because in the V star we have all the collection of linear functionals on V, that is F1, F2 up to so on. Okay, and it is defined by L alpha of F is equal to F alpha, F of alpha. Okay, for all linear functionals belongs to our domain. What is domain? V star. Okay, now we have to prove that this function L alpha on V star is a linear functional. Linear functional on V star. ओके, हा जो फंक्शन डिफाइन केलेला तो कसा आहे? लिनियर आहे हे आपल्याला प्रूव्ह करायचं. लिनियर फंक्शनल आहे म्हणजेच काय होईल? दॅट इज वी हॅव टू प्रूव्ह दॅट धिस L अल्फा बिलॉंग्स टू V डबल स्टार. इज इट करेक्ट? एखादा फंक्शन जर या V स्टार वर लिनियर फंक्शनल असेल, इफ एनी फंक्शन defined on V star, if it is linear functional, then it belongs to then V double star. Okay, that is we have to prove that here this L alpha function is linear functional on V star. That is we have to prove that L alpha belongs to V double star. Okay, any doubt up to here?
No, sir.
And also a mapping. Also we define one mapping alpha to L alpha. ओके, अल्फा कुठून येतो तुमचा? V मधून. L अल्फा कुठे आहे? V डबल स्टार. ओके, we define one mapping V to V double star. Okay, also a mapping alpha to L alpha. Okay, is an isomorphism. Okay, is an isomorphism of V onto. Okay, so onto पण असेल. Into isomorphism. Onto isomorphism V onto V double star. Okay, look at the statement once again. Let V be the finite dimensional vector space over the field F. If alpha is any vector in V, then the function L alpha belong on V star defined by L alpha of F. Okay, why? Because the all the V star is nothing but collection of all the linear functionals on V. Okay, this is the set V star. So input is F here. L alpha of F is equal to F of alpha for all F belongs to V star. We have to prove that this function is linear functional on V star. That is L alpha belongs to V double star. And also we define one map alpha to L alpha, that is V to V double star is onto isomorphism. Okay, any doubt? काही न समजण्यासारखं आहे का स्टेटमेंट? असेल तर विचारू
No,
शकता.
sir.
Okay, now we will see the proof. Let write down all the given things first. Let alpha be a finite dimensional vector space. Be a finite dimensional vector space over F, over capital F. And let again, sorry, not let V now. Let V be a finite dimensional vector space over. Okay, and let now alpha be any vector in V. Any vector in capital V. Again, and L alpha be a mapping. Be a mapping defined on V star. Defined on V star by L alpha of F is equal to F of alpha for all F belongs to V star. Give it as an equation number 1. Now, the first step, we have to prove that L alpha, this function, is linear functional. Okay, on V star. जर माहिती नसेल तर हा लिहून घ्या सेट. Okay, in the bracket V star is equal to collection of all functions such that F is the function from V to capital F, which is linear. Okay, this set complete. And V double star is equal to collection of all linear functionals on V star to F is linear again. Now we have to prove that this L alpha is the linear functional on V. म्हणजेच L alpha belongs to V star हे आपल्याला प्रूव्ह करायचं. Now let आता अल्फा 1 and अल्फा बीटा बी एनी टू वेक्टर्स नाही असे नाही येणार. Let F1 and F2 be any linear functional. Okay, on V, that is इनपुट घ्यायचा ना तुमच्या डोमेन मधले दोन एलिमेंट घ्यावे लागणार तुम्हाला. F1 and F2 be the two any elements from V star. Okay, and take one scalar belongs to F, be any scalar. What is the linearity condition? If L alpha of CF1 plus F2, L alpha of CF1 plus F2 is equal to, by the definition of mapping, what we have? This is CF1 plus F2 of alpha. हा तुमचा रूल डिफाइन केलेला. Okay, from 1. Okay, from equation number 1. Look at the equation from the definition of L alpha. Okay, Now operate this alpha on both the functions f1 and f2. This is cf1 of alpha. कसा ऑपरेट होणार ह्या दोघांवर आणि हा f2 of alpha. Okay. What is the reason? By definition of addition in V star. V star is a vector space आणि वेक्टर स्पेस मध्ये तुमचं ऍडिशन असल्यामुळे कसा काय होईल असा ऑपरेट होईल cf1 of alpha plus f2 of alpha, but f1 is linear, so which is equal to not f1 linear, c into f1 of alpha is equal to c into f1 of alpha plus f2 of alpha. What is the reason for this one? By definition of scalar multiple. Okay, dot in V star. Is it correct? हा V star तुमचा काय वेक्टर स्पेस फॉर्म होते. Okay, any doubt?
No, sir.
So which is equal to c into what is f1 of alpha? L alpha of f1 by the definition of f alpha, L alpha. Okay, plus what is f2 of alpha? L alpha of f2. Okay, so hence we get L alpha of c f1 plus f2 is equal to c into L alpha f1 plus L alpha f2. ओके, म्हणजे आपण जो मॅप डिफाइन केलेला आहे रूल तो कसा आहे लिनियर. हेन्स L alpha is linear functional on V star. Hence L alpha is linear functional on V star. That is L alpha belongs to V double star. Any doubt?
No, sir.
Now in the second case, second step, this one is step number 1. Step number 2 now. To prove that a mapping, okay, define one map from alpha to L alpha. A mapping alpha to L alpha is an isomorphism. Isomorphism. Isomorphism of V onto हा तुमचा अल्फा मी बदलना है L alpha V double star. Okay, now define one mapping. Define a mapping psi from V to V double star defined by psi of now काय असेल इनपुट तुमचा psi of
Alpha.
alpha is equal to L alpha for all alpha belongs to V. Okay, give it is an equation number 2. To prove that psi, the mapping psi is isomorphism. To prove that psi is an isomorphism. Psi is an isomorphism. Okay, that is 1 onto a linear transformation. Step number 1. In the second step, step number 1, to prove that psi is 1. Okay, let alpha and beta belongs to V be any two vectors in any two vectors, then psi of alpha is equal to L alpha by the definition of psi. Psi of beta is equal to L beta. Okay, by the definition of psi now. If we have to prove that psi is 1 1, what is the assumption? What is the step to prove the psi is 1 1? एखादा फंक्शन 1 1 दाखवण्यासाठी काय करतो आपण? आधी काय अजूम करतो आधी? Two images are equal. If the three images are equal, then that function is 1 1. So assume psi of alpha is equal to psi of beta. Is it correct?
Yes, sir.
So this implies by the definition of psi alpha, this is L alpha, which is equal to L beta. Okay, हा तुमचा L alpha आणि L beta कुठे आहे? L alpha and L beta belongs to V double star. That is L alpha and L beta are the two linear functional on V star. Okay. So apply, okay, this L alpha and L beta on linear functional on V star now. Linear functional on V. So L alpha of operate this alpha on F and this L beta on F again. Okay, हे जर दोन इक्वल असतील तर त्यांचे इमेजेस पण इक्वल असायला हवेत. ओके नाही, ऑपरेट करायचं L alpha. Images नाही, sorry, not images. These two function f is equal to जर g असेल, if two functions are equal कधी म्हणतो आपण? F of x is equal to g of x for all x belongs to our domain. Is it correct?
Yes, sir.
तसंच L alpha is equal to L beta. When we say that if f L of alpha of f and L beta of f for all f belongs to V star. Is it correct?
Yes, sir.
Okay. By the definition of L alpha of f, what we have? L alpha of f म्हणजे काय तुमचा? F of alpha. L beta of f is nothing but f of beta. Okay. By definition of L alpha and L beta. Look at here. कसा डिफाइन केला L तुमचा इथे? Okay, L alpha of f is equal to f of alpha. L beta of f is equal to f of beta. Okay. So this implies f of alpha minus f of beta is equal to 0. Okay, हा तुमचा आउटपुट f मध्ये जाईल, म्हणजे f मध्ये फील्ड आहे. F is a field, so there exists an additive inverse in f. Okay, so that implies f of alpha minus f of beta is equal to 0, but f is the linear functional. That means f of alpha minus beta is equal to 0. What is the reason? F is linear. Okay, if f of alpha minus beta is equal to 0 for what? For all f belongs to काय? ही कंडिशन असं येईल खाली. Of f belongs to V star. This condition holds. So this implies if f of alpha minus beta is equal to 0 for all f belongs to V star, then alpha minus beta it must be 0 vector. Okay, by previous corollary. Is it correct?
Yes, sir.
What is that corollary? If f of alpha is equal to 0 for all f belongs to V star, then V is equal to 0. Sorry, alpha is equal to 0. Okay, this corollary. So this implies alpha is equal to what? Beta. Hence, psi is 1 1. Any doubt?
No, sir.
Now, in the second step, we have to prove that psi is onto B part. To prove that psi is onto. Okay, since dimension of v is equal to what? Dimension of v star. ओके, कशावरून लिहिला हा स्टेटमेंट? काल एक नोट पाहिला होता बा. बीटा इज आयसोमॉर्फिक, बी इज आयसोमॉर्फिक टू बीटा स्टार. ओके, बी इज आयसोमॉर्फिक टू बी स्टार म्हणजे ह्याची ऑर्डर आणि ह्याची ऑर्डर काय असायला हवी? सेम. ओके, राईट डाऊन इन्स्टेड ऑफ बी इज बी स्टार इज आयसोमॉर्फिक टू काय असेल? बीटा डबल स्टार म्हणजे ह्याची डायमेन्शन आणि ह्याची डायमेन्शन कशी असेल? सेम. ओके, so hence dimension of B is equal to dimension of B star. So here the dimension of, sorry, order of B is equal to order of B double star. Hence the dimension of V is equal to dimension of V double star. And we have psi is 1 1. एखादा फंक्शन, एखादा लिनियर ट्रान्सफॉर्मेशन 1 1 आहे आणि डायमेन्शन ऑफ V इज इक्वल टू डायमेन्शन ऑफ V डबल स्टार जर असेल तर तो काय असतो? फंक्शन
onto.
ऑन टू फंक्शन असतो. ओके, हेन्स एखाद्या सेटमध्ये पहा, आता इथं वेक्टर स्पेस आहे म्हणून डायमेन्शन आहे. एखादा फायनाईट सेट आहे, त्याच्यात सुद्धा 4 एलिमेंट आहेत, 5 एलिमेंट आहेत समजा. ओके, देर आर 5 एलिमेंट्स इन सेट ए अँड दिस इज सेट बी. इफ सेट दिस इज 1 1, 2 3 4 5 ह्याच्यात 1 1 अँड ऑर्डर ऑफ ए इज इक्वल टू ऑर्डर ऑफ बी, then the function f is must be onto. एखादा फंक्शन 1 1 असेल आणि ऑर्डर ऑफ डोमेन अँड कोडोमेन सेम असेल तर तो फंक्शन ऑनटू असतो. ओके, now here in the vector space, if dimension of v is equal to dimension of v star, v double star, and psi is 1 1, hence psi is onto. Okay, any doubt?
No, sir.
Okay, wait a minute. Okay, so here the psi is onto. Okay, hence for each, what is the meaning of onto? Hence for each L alpha belongs to our codomain V double star. Okay, there exists alpha belongs to V such that psi of alpha is equal to L alpha. Okay, now in the third step, we have to prove that this psi is linear transformation. This psi is linear transformation. Okay, now again take two vectors. Psi तुमचा फंक्शन कुठे आहे? V2 V डबल स्टार. ओके, फंक्शन कुठून कुठे लक्षात असायला हवं. सो let take any two elements alpha and beta belongs to V. Okay, V any vectors and C belongs to capital F. B any scalar. So we have to prove that psi of C alpha plus beta is equal to C into psi of alpha plus psi of beta. Okay, consider again. Psi of C alpha plus beta, C alpha plus beta is equal to, what is the definition of psi? This is L of C alpha plus beta. Okay, give it as an equation number third. Now operate this L C alpha plus beta. हा कोणता एलिमेंट आहे? V स्टार मध्ये, V डबल स्टार मधला एलिमेंट. ओके, सो L याची व्हॅल्यू फाइंड आउट करायची आपल्याला. ओके, सो L C alpha plus beta on the functional f, which is equal to, by the definition of L. So what we have? F of this is
F of C alpha plus beta.
beta. Okay, by the definition of L alpha. But F is what? F belongs to V star. V star is vector space. Okay, collection of all the linear functionals on V now. So this is C into F of alpha plus F of beta. Why? Because F is linear. Okay. But what is F alpha? L alpha of F plus this is L beta of F. Okay, so this implies L C alpha plus beta of F is equal to C into L alpha of F plus L alpha of L beta of F. Okay, so this implies L C alpha plus beta is equal to C into C into L alpha plus L beta. Okay, is it correct?
Yes, sir.
Now putting the above value in equation 3. So from equation third, we have psi of C alpha plus beta is equal to, look at here from equation third. L C alpha plus beta ची value काय आली? C into L alpha plus L beta. C into L alpha plus L beta. Okay, what is L alpha? C into psi of alpha. Is it correct? Plus psi of beta by definition of psi. Hence, the mapping is linear transformation. Hence, psi is linear transformation. Thus, the mapping alpha to L alpha is an isomorphism. Okay, of V onto V double star. Okay, any doubt?
No, sir.
म्हणजेच काय, जर या सेटमध्ये तुमचा अल्फा असा दिसत असेल नंबर तुमचा कोणताही एक एलिमेंट, तर ह्याच्यामध्ये कसा दिसेल तो? त्याच्यात बीटा असेल तर ह्याच्यात कसा दिसेल? ऑल द प्रॉपर्टीज होल्ड्स बाय व्ही अँड व्ही डबल स्टार सेम, मस्ट बी अ सेम. ओके, कळते? इंग्रजीमध्ये जर 1 2 लिहिलं तर कसं दिसेल आपल्याला? 1 2 3 4 5. आणि मराठीत लिहिलं असेल तर 1 2 3 4. ओके, दिसायला जरी वेगवेगळे असतील तर ते कसे असतात? त्यांच्या प्रॉपर्टीज सगळे होल्ड करणारे सेम असतात. हेच मिनिंग आहे आयसोमॉर्फिझम. Okay, so here the V is what? Isomorphic to V double star. Any doubt up to here?
No, sir.
Okay, समजते काय चाललंय? काय डोक्यात तुमच्या ते सगळं?
समजते, सर.
आवाज व्यवस्थित येतोय?
Yes, sir.
जर आवाज व्यवस्थित नसेल तर सांगा मला इथेच. ओके, म्हणजे माझा आवाज वाढवावा लागेल मग. ओके.